So in this case, a farmer has $1,500 available to build a fence along a straight river to create two identical rectangular pastures. So we have, let's say this is the river and rectangular. Okay, let's say this is rectangular. It's not a nice picture, but it's rectangular and two identical. The materials for the side parallel to the river, this is parallel to the river, cost $6 per foot, and the materials for the three sides perpendicular to the river cost 5 per foot. Let's say this length is y and these are all equal to x. No fence required along river. So the cost for this side is $6 6 times y, 6y. So the cost of this fence is 6y, and the cost of this side is 5 per foot, so 5x, another 5x, another 5x, so 15x plus 6y. So the total cost is $1,500. That's the dollars available funding. So that's the constraint. So in this case, okay, so the constraint is 6y plus 5x, 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 so 15x is 1,500. And we always want to solve for one variable. Let's solve for y. Subtract 15x from both sides and divide by 6. We get y equals 1,500 minus 15x divided by 6. We could simplify, but we'll do that later. Anyway, that's the constraint. Now the objective function is find the dimensions for which the total area of the pastures will be as large as possible. So we want to maximize the area. So area is, this is y times x, or x times y. So the area, let's say A equals x times y, and we can replace y from the constraint. So x times y is now 1,500 minus 15x over 6. Let's distribute and simplify, because we need to take derivative in the next line. So x times 1,500, that's 1,500 x over 6. I split it into two fractions as well, minus x times 15x is 15x squared over 6. If we simplify, 1,500 divided by 6, so half, 750, thirds 250. So this will be 250x, you can use calculator, minus 5 times 3 times 5, 3 times 2, so 5 halves x squared. So that's the objective function, let's say a as a function of x. Now we want to take the derivative of this objective function, so that will be 250 minus 5 halves times 2x, 5 halves times 2, this is 5x, and we want to set the derivative 0 to find the critical numbers. That implies 250 minus 5x equals 0. Move 250 over, negative 250, divide by negative 5, so x will be 250, negative 250, other side, divide by negative 5, so that will be 50. So this vertical side should be 50 feet long, so 50, 50, 50, and this should be, now we just plug in x equals 50 in the constraint and find the corresponding y. Okay, so but the question is why x equals 50 maximizes the area. For that we find second derivative. The second derivative, this is the first derivative, so 250 minus 5x, derivative of 250 is 0 minus 5, so negative 5, which is negative. So second derivative is always negative. That means the critical number will produce maximum value. Okay, implies x equals 50 maximizes the function, which is area in this case. Thus the dimensions are, the x part is, we already found, here's the 50 feet by width. Plug in x equals 50 in this constraint. Okay, so 15 times 50, 750, 1500 minus 750, 750 divided by 6. Okay, that will be 125. That's fit. Final.